Alright, so in the previous video, we briefly touched upon the fact that the differentiation and integrations are opposites or reverse processes, right? So remember this diagram here where we had y or f of x. If we differentiate it, we get dy by dx or f prime of x. And so if we were given the derivative, we would have to integrate to go back to the function. So this is what we're going to try and do. We're going to try and find the original function if given the derivative. Let's look at an example. So let's say I have the derivative f prime of x is 2. Now if I integrate this, I'll get f of x, right? So f of x will be the integral of f prime of x dx. So let's integrate 2. This is going to be 2x plus c. Now this is just going to be the function f of x, and it's going to be a straight line. Now this c value, this integrating constant, can be found if we're given a certain condition. So in the exam, they will give you a certain point, for example, 2, 0 or like 5, 2, in which case after integrating, after getting this function, I can plug it in to find my c value. Let's try an example. So let's say I have this f prime of x, which is 9x squared plus 4x minus 3, and I want to find the original function. Then I'll just have to integrate it. So let's go ahead and integrate it. This will give me 3x cubed plus 2x squared minus 3x plus c. That's my f of x. And they've told us that it passes through the point minus 1, 0. So what I can do is saying, well, x is going to be minus 1, then f of x is going to be 0. So I can just plug it in. So I can say that 0 is equal to 3 times minus 1 cubed plus 2 times minus 1 squared minus 3 times minus 1 plus c. Solving for c gives me 2. This means that the function itself, the final form, will be 3x cubed plus 2x squared minus 3x minus 2. That's how we find the original function from the derivative. Let's practice another question. This is more like a modeling question now, right? So originally we are given f prime of t, and that's minus 9.8 t. And so they want us to find the original function f of t. So first thing we do, integrate it. If I integrate this, I get minus 4.9 t squared plus c. We need to find this integrating constant, which we can do because they've told us that f of 0 is 35. So plugging it in will give me that the integrating constant c is 35. So my final function f of t is going to be negative 4.9 t squared plus 35. In part B, they're asking us what is the value of the height when t is 1.5. Just plug in 1.5 to t, 23.975. Pretty simple. In part C, they want us to find the total height, and that occurs if you're to look at the diagram when t is 0, right, initially. So I just plug in f of 0, which gives me 35. And finally, for the last one, they want us to find the time taken for it to reach the floor. For it to reach the floor, it means that the function f of t has to be 0. So I just say 0 is equal to minus 4.9 t squared plus 35. T is 2.67. So you can see that if we are given a derivative, then we can find the original function by just integrating and finding this integrating constant.